Yeah, can. How about me? You can. No, it's fine. Hang on. I'm gonna have to use my PowerPoint to do this. Questions are questions. We will know what you have problems with until we start doing the questions. Okay, what's up? Okay. No, so it's very important for geostationary to be above the equator at all times. Like when we say that when we say it's geostationary, we actually mean that it is actually geostationary above a certain point on the equator. So it is a requirement for geostationary satellites. If let's say this is the planet and that's the equator there, right? That's the equator over there. It's very important that the satellite must be directly above the equator and orbiting over the equator at all times. Yeah. Because so the thing is that if like so the question is can the satellite be geostationary to other points of the Earth? Right. The answer is no, it can't. Right. Hang on. I need to get some real estate around here. Right. So it can't. Simply because so the idea here is that if let's say this is planet Earth, right, and this is the equator again. Okay, something like that. And then there's a satellite that's here. So a geostationary satellite definitely needs to be directly above the equator at all times. If you try to do any other point, that means Singapore, Singapore kind of like there's a geostationary, there are a few geostationary satellites above us. So if you were to look up into the sky directly, you should see, like if you have super bionic eyes, you should be able to see a couple of geostationary satellites directly above us, right? Then so the question would be, how about someone else in like in Norway, for example. Norway is somewhere around here, right? Okay, like there's Norway over there, right? That little sliver over there. Like, could we have a geostationary satellite that's above Norway at all times? So the answer to that is you cannot have a geostationary satellite doing a halo orbit like this, right? Um, the explanation for this is a lot more extensive, but essentially, the gravitational force that acts on the satellites that provides for the centripetal force, right, is acting towards the center of the planet. So if you look at a green orbit, that satellite is not the center of the satellite, the center of the orbit is doesn't coincide with the center of the Earth like this, right? No, I think it's more like eventually it will just like, eventually it wouldn't if it would not even do this sort of orbit. It will do this sort of orbit like that. Like it will be a diagonal orbit. Okay? Yeah, because the center of the circle must always coincide with the center of the Earth, right? So therefore it needs to be, yeah, yeah. So the only, yeah, yeah, yeah. So there are three requirements for geostationary orbits. The three requirements being, it must have the same it must have the same period, 24 hours. It must be above the equator, right? And it must orbit with the same as the Earth's rotation, which is from west to east. Okay, from west to east. Now, if all these you don't understand, make a mental note. Please go and watch the recordings when you have the time after the paper. But obviously, this is us discovering that you might have a gap regarding geostationary satellites. So regarding this, okay, so you might be asking, oh, like if all geostationary satellites must be above the equator, does this mean that other countries do not have geostationary satellites? Not at all. So a geostationary satellite has wide coverage. Okay, so if you can see, the geostationary satellite has this like coverage from this orange line to the other orange line, so it covers a lot of all the countries. So it is still geostationary to these places as well, except it just doesn't appear directly above. For Singapore, if you are standing outside in the open and you look up above, right, there will be satellites directly above. But for other countries of the higher latitude and the lower latitude, right, they basically, like, wherever they're standing at from their perspective, their geostation that very same geostationary satellite is actually just above the horizon, right, just above the horizon, from where they're looking at, and it's always at the same spot above the horizon. So, you know, that's what the geostationary means. It means that it looks like it's always from from the satellite's point of view, it's always directly above a point on Earth on the equator. From the Earth person's point of view, the geostationary satellite always appears in the same spot in the sky at all times, right? For Singaporeans, right, the satellites are directly above us. For higher latitude, like observers, the satellite is always a point in the sky in front of them, right? Yeah, that's what this means. Like the in the plane of the equator, actually that kind of like means that if we were to like kind of like half the the Earth like this, this is like the plane of the equator, like that's what they're saying. So the satellite is orbiting around this on this plane, right? Yeah. Yeah, something like that. And also do take note that I mean, geostationary satellites is a very like it's a very frequently asked question. They may ask questions like, if I have another geostationary satellite, would it definitely be at the same orbital radius? Let's say I have a small geostationary satellite and a big one, right? Both of them are geostationary, so which means that will they both be at the same orbit? Like, will they have the same distance away from the center? And the answer is absolutely yes. It's absolutely yes. I mean, the n cancels out, yes, and t squared is proportional to r cubed. This is Kepler's third law, right? It tells us that the period. So if both of them are geostationary, and therefore both of them must have a period of 24 hours, then that means that both of them must have the same orbital radius. So you're missing all that. Make a mental note. After the exam, you have to catch up on that. Okay? I mean, I can do a quick revision on it, but don't rely on that because, like, there's like a million things for me to go through. Just make sure that either you make sure that I go through it, or you just catch up on the videos. It's all provided to you, okay? All right. So we have this one here. So there's a oh gosh, fixed mass of an ideal gas at 100,000 pascals, 300 kelvins, 0.01. Total Ke of the molecules after the volume is changed to what's the total kinetic energy, is it? Of the After the volume is changed to 0.005 at constant temperature. So the thing is, this is a bit of a trick question. PV equals nRT. All right, PV equals nRT. Um, U is equals to 3 over 2 PV, internal energy. So U is equals to 3 over 2 nRT. What this means is that the internal energy of an ideal gas, right, is directly proportional to the temperature. So if the temperature remains the same as before, right, same temperature, right, then the internal energy remains the same as before. So that don't change. Okay, so it's still the same as before. But of course, then you go back and it's like, okay, but I need to figure out what's before, right? So we need to go back and then go and find out what's the um yeah. Well, yeah, basically it is, yeah, because total KE of an ideal gas is the total internal energy. So ideal gas total KE equals to the internal energy. And 3 over 2 PV, what you should be able to get something. What's the answer though? Okay, right. So there you go. All right. Then the next one will be for what's this? Okay, what do we have here? No, no, no. Hang on, wait. Let me see this. X and Y are adjacent positions that gives you maximum amplitude on the oscilloscope as shown. Is it? Okay. So this is only when it's at X. Yeah. Okay. No. So you did recognize that X and Y are antinode. So this is an antinode. That's an antinode, right? So you got to remember that antinode and antinode, that's half a wave. Yeah, so the distance between one antinode to the distance of the other antinode, that's half a wavelength. It does, it does, like right here. Mm-hmm, mm-hmm. No, this got nothing to do with harmonics. Take your time. Yeah, antinode to antinode. Didn't you start off with saying that you know that X and Y are antinodes? Okay. No, adjacent. So immediately after that one, the very next antinode. It's just that for X and Y, if X is an antinode and Y is an antinode, at any time X displacement is negative and Y displacement is positive, but they are still the antinodes, right? Yeah, yeah. So that's half a wavelength. Yeah. This one's okay. You can figure out the wavelength. Okay. Uh, Hang on. Let me just take a quick look at this one here. Adjacent, adjacent. Hang on. Let me just change this up. Uh-huh. Uh-huh. Okay. X is it? All right. So do you recognize that this projectile motion? No, it is projectile motion. So charged particle in an E field is like, if it does a curve, that's projectile motion. If it's a charged particle in a magnetic field, that's circular motion. Do you understand that? Okay. No. So oil droplet suspended, right? So if it's an oil droplet case, wow, dude, you better go and catch up on all the E field videos, man. Like G field and E field seems to be a big problem for you. G fields and E fields and the applications of G fields and E fields, right? Make a mental note, like you need to cover all this. You won't hear, you won't hear, you won't hear when I was doing G fields and E fields, right? Huh? Really? Whoa, that's not good. Um, so you, no. There's not much to grasp. It's exposure. So you got to expose yourself to many different scenarios. I mean, with regards to G fields and E fields, is pretty straightforward. There's force, there's field strength, there's potential, but there's potential energy, right? And the force is either it's being attracted or it's being repelled for E fields, and then for G fields it's just being attracted. I think what you really need to drill down on is the multitude of scenarios that they can get, which means that you probably have to go through a lot of different scenarios, right? To kind of like, but you're applying the same concept though, as in like, yeah, you're applying the same concept over and over again, but you really need to drill down. Like, I mean, not drill down. It's like you really need to gain exposure. Yep. So if you're talking about oil droplet, right, which is this one here up here, this oil droplet, the electric force is equals to the weight. So the oil droplet is suspended. So if it's suspended, then that means that the forces are balanced. But this is not, right? This is a proton, right? It's a proton, and it's being projected into an E field like this, right? So yeah, this projection comes from somewhere else. Like something else caused it to project in the first place, and therefore it starts to fly and it flies into the parallel plates. One side is positively charged, the other side is negatively charged, right? I know it's being earthed, but if a plate on top is positively charged and this one is being earthed, then I know that this plate is 0 volts, right? But it's negative in relation to the positively charged plate. You get what I'm saying? Like zero is relative is negatively is relatively negative to positive, right? Positively charged plate. So what happens what happens is that this charge will experience a downwards force, right? So and therefore there will be F equals to ma, QE equals to ma, A equals to q uh, A equals to QE over m, right? Do you understand all these letters? Okay, all right. So so you need to recognize its projectile motion, because you need to remember what's the definition of projectile motion. It is constant, eh, constant, no, okay, constant velocity in one direction with constant acceleration in the perpendicular direction. So for this proton, it started off with an initial v. This horizontal v was constant throughout the entire motion. So as this guy started to fly into the field, right? Started to fly in the field, right? This guy always had the same horizontal component of its velocity. Yes, his overall velocity does change because the vertical velocity starts to increase, but at any point in time, if you were to check its horizontal component, right, it's always going to be the same. Right, his horizontal, velocity will always be the same, something like that. Okay, but the downwards velocity does increase because he's accelerating towards the plate. Notice how that the bending stops after it comes out. Okay, the bending stop comes in after it comes out. So this is just straight up projectile motion, which means that you need to recognize that this x here is in the vertical direction. It's a negative s, right? Yeah, it's the negative displacement, right, of an object in projectile motion. So if you are but projectile motion is very far away for you. So if you're not familiar with projectile motion, maybe you have to get a recording on that as well. Right? So S equals to UT, plus half AT squared, right? S equals to UT plus half AT squared. So you have like kind of like I will put it at negative x equals to, so it's vertical, so 0 plus half. Then the A comes in here, right? Half QE over M, right? And then you got a T squared there, right? So one of the big problems that you see is that we don't see any T. So we need to sub out T. So once we are done with the vertical, so this is for the vertical, we now have to look at the horizontal. Okay. So by looking at the horizontal, we got this value here. This is y. Okay. We understand that the horizontal velocity is constant. So v is constant. So like if what happens if I take y divided by v, right? That would be the time taken, right? So v is equals to y over t because it's constant. There's a horizontal, and horizontal is a constant velocity. So t is equals to y over v, and then we sub that inside here. And then when we kind of like wrap it all up, it should look like this. QE over 2m, and then we've got the y over v squared, something like that. Uh, it looks like they don't have E, right? They're trying to be funny again, so we need to swap out E. Yeah, V over D. Uh, what am I looking at? Is it A? Yeah, it's A. Yeah, there you go. Right, yeah. Okay. Yeah, so that's for this one. Uh, uh-huh, uh-huh. Current of X is towards the top. Magnitude of force on X is F. And you straight up will just cancel out this one and this one. These two are wrong because it must have the same force. And the rule is this. I don't know why you don't remember this, but I think I went through this a couple of times before. When the currents are in the same direction, then the force will point towards each other. So it has to be C. I kind of like, no, I did mention during electromagnetism, you can work it out. I wouldn't recommend you to. Just remember that when the currents are in the same direction, the force is towards each other. I did explain how to figure it out before, right? But whatever it is, right? Whatever it is, you know that the current same direction forces towards each other. So C has to be the answer, right? And if you tried doing the right hand grip rule and the left hand rule, and you realize that you're not getting C as the answer, then which means it just means that the way you're using your right hand rule and left hand rule are completely wrong. Yeah. Yeah, no, as in like I don't need you to tell me like like you made a mistake or anything like that. That's actually not my big concern. My big concern will be like did you get it the right way? So usually, I mean, if you had to really go and work it out, if you really wanted to work it out, it will be something like this, right? No, no, kind of like no, so here's the thing. What I'm trying to tell you is the strategy here is that there's no need for you to go and work it out. You know that the two currents are in the same direction, the force points with each other. That's that. All right. I think that's the one mark here. Like this question doesn't even take like more than 5 seconds for you to figure it out. Okay. But if it does come out that you are supposed to choose a diagram to show how it works, you got to remember that the magnetic field of one wire is cutting the other wire. So so you use your left hand rule, right? The magnetic field of X is cutting into the page, right? Into the page for Y, okay? And then Y has a current that's pointing up. Use your left hand rule on Y, and then you should be able to see that the force does point towards the left side here. Yeah. Okay. And you repeat the same thing for the other side, and for the other side, the magnetic field is pointing out. This will be like the magnetic field of Y, right? So you use your right hand grip rule. Yeah. Okay. All right. I don't exactly know what you're talking about. What do you mean by when the magnetic fields combine? I am concerned about the way that you memorize things. Um, Hell no, don't do that. That is wrong. Yeah, don't do that. That is the number way one way to get it wrong. Yeah, yeah, don't do that. That shouldn't be your way. That was a coping mechanism, but that was not the real way of trying to understand why is it like that. Uh, Hang on, let me just double check everything and hold up. Let me see. Did I not do the wires one? Why don't I remember doing the wires one? Hang on, I'm trying to figure out where's the one where I did the wires at. Or was it something that I sent in the group chat and asked her to just go? Did I miss the wires one? God damn it. The double wires one. I'm just trying to scroll through my videos. I know, but I can't for the sake of my life find it though. Is it because no? Wait, hang on. Did I accidentally? No, it's 23rd of March to this one here. This is the previous one was 24th. So hang on. Let me just double, triple, quadruple check everything first. These are all EMIs. So when did I go? When did I do that thing that I said I did? That's hella weird. Huh. It must be somewhere. Well, I can always refer to my older ones. Okay, maybe it's here. No, it's not. It's not that one. I don't get it, man. Why do I not remember where the shit is? Hmm. Yeah, okay. Yeah, go ahead. Nah, that's true. Yeah, it is. So, I think what you have is an issue where you kind of like you just tell yourself that every time I see the magnetic field going like that, and then therefore the force will be like this, right? So you kind of kind of like simplified it in your head to thinking that oh, when the magnetic field is like this, it causes the force to be towards each other like that. That's not the exact explanation. Yeah. Yeah, you would have to do individual right hand grip rule and left hand rule to figure out that the force is actually acting towards it. So there's this idea of like, correlation and causation. So like, yeah, the magnetic field like this, okay, is correlated, like this peanut shaped thing is correlated to how the force acts on each other. It's like, it's, yeah, it comes together, but it doesn't cause it. You see, so this is me drawing it to show you like how do I show that it causes it like that, right? Yeah. And especially, I mean, and especially in your this question here, right? You did notice that the question here, that you see in front of you, it's yo, what the hell is my question? Where's the question? Oh, did I delete it? Yeah. So they did give you two different currents. One is 2 amperes, one is 3 amperes. So it turns out that one of the magnetic fields is stronger. So BX is weaker, BY is stronger. So X experiences a stronger magnetic field from Y. Y experiences a weaker magnetic field from X because X has a smaller current. But at the end of the day, the force acting on each other is the same because you have to multiply the flux from one of them onto this guy's current. So you get a strong magnetic field from Y, but you get a weak current, and then you get a weak magnetic from X, but you get a strong current. So it calculates out to be exactly the same. Yeah, yeah. Right. No, you can understand versus you can, you understand it in depth lah. That's a really important thing because I'm kind of concerned about like, not you in specific. Like I'm always concerned about students who memorize things, so that they just memorize it without knowing why it's like that. Peak would be I naught, yeah, right. So if you want to do the RMS, you probably will have to really go around. No, there's only one answer, isn't it? Yeah. Yeah, you don't have to care, right? I mean, it's like for this 1 mark here, 5 seconds, right? But if you had to do it, then we have to do it. Do you know what root mean square means? Like, what do you have to do? So you square the peaks first, yeah. So this will be, the I naught square and then one period, right? And the area will be equals to I naught squared over t. Sorry, I naught squared t, and then the mean will be equals to, oh shit, wait, hold on, isn't it A? Wait, that don't make sense. Yeah, it's A, right? No, it's A, it's A, it's A, it's A, not B. Yeah. So the mean is I naught squared over T, right? So when you mean something, you take the area and you divide it by the time, right? So it will be area over T, so area over the time, and then you RMS, you root whatever it is. So if you root this one here, it becomes I naught. So yeah, so A is the answer. Yeah. Ah, um, yeah. No, so here's the thing. What I want you to do is that if you understand it now, the thing is that you need to lock it in, and if you want to lock it in, you would have to write it down yourself like this. Okay? So you can't just look at something only, right? You got to write it down. All right, let's look at the next one. This one is the number one most difficult questions ever in the uh, you know, like in the A level TYS, right? So this thing here is it gets students every year. So yeah. Yeah. This thing is a bitch. Um, hang on. So they're asking you at what point, or rather, where is the new center of gravity, right? Yeah. So you're basically trying to find out where's the new center of gravity. Okay. So the new center of gravity will be somewhere around here, I suppose. right? But the question is, of course, like, let's try to figure out like exactly where it is, right? Mm. So do you understand that the center of gravity is a point whereby if you place that object, like, you put a pivot, like you put a pivot, right? Let's say you put a pivot directly below it, okay? Yeah, I know, I know. What I'm saying is that, if you were to take this piece of cut out metal, and the center of gravity is there, and then you kind of like just put your hand directly under that point, right? You literally can balance it. You understand that, right? Okay. Um, the original center of gravity would have been somewhere. It would be right in the middle here. That's the original center of gravity, right? Okay. Uh, the new center of gravity here, this one here, the blue one, is the new weight of this piece. Okay. What that means is that if you had this diamond shaped piece, right? If you had this diamond shaped piece of metal still there, right? It would have been balanced in the middle. You understand what I'm saying? So what that means is that the weight of your new piece of metal, right? The weight of your new piece of metal from whatever distance it is from the midpoint, okay? Presence in the form of absence would have balanced, right, the weight of that missing piece if you tried to balance it in the middle. This is the hard part to understand. This is like the philosophy of it. Okay, yeah? So one more time. Okay. I use blue though. Okay. So the blue cross, what does it represent? Yes, for the piece of metal that has that piece cut off, right? That's a new center of gravity. Correct. Um, it's there instead of where? Like it's yeah, instead of the yeah, at the red center, right? Okay. So so the reason why the center of gravity shifted from red to blue is because someone went to cut that piece out. Okay? All right. If you take that piece and you put it back here, if you take that diamond shape and you put it back inside here, right? Will these two balance off each other? And therefore the new center of gravity, if you put the piece back inside, where's the new center of gravity? It would have been, it would go back to the center. So the weight the weight of the blue, that means the one with the hole, right? The weight of the blue, right? The moments by this blue one about point X, the red one, about the pivot, the red pivot, balances the moments that was like supposedly due to the cutout here. You know what I'm saying? Okay. So if that's the case, then what you need to do is you need to figure out what is the mg of this thing. Firstly, the mg of this thing, cut out. So what's the mg of that? So is that a quarter of the entire thing? Okay. So am I right to say that if I take the whole piece as mg, then it's just 1/4 mg? Okay. So 1/4 mg, okay, multiplied by how far are you away from the red pivot? 2 cm, right? 1/4 mg, right? Multiplied by 2 cm. So since you know that you cut out a quarter there, then that means you are left with 3/4 here. 3/4 mg, right? Multiplied by what distance, right? X, okay? Or maybe even I'll just put it as d, right? So we don't know what d. Wait, is it okay? So we don't know what d is from the pivot, right? But yeah, 3/4 mg times d is equals to 1/4 times 2. So 3/4 mg based on moments times d is equals to 1/4 mg, right? Times 2, right? So our understanding is d is how much? 0. Yeah, okay. So 2 over 3 cm, right? 2 over 3 cm. So the question did ask you what's the new center of gravity of the from P. So they kind of like threw you another stupid curveball where they want you to figure out, yeah, so the new center of gravity, right? Hang on, this stupid line is giving me grief. From here all the way to here. So that's 4.67. So yeah, 4.7. Yeah, no. So this is one of the more challenging questions. It has happened. It has popped up like once or twice before. So this kind of questions is kind of like I call it the philosophy question, um, whereby you have to figure out that the it's basic. I call it the presence in the form of absence. So like if the piece of metal was back there, right, the center of gravity would have been in the middle. So in a way, since you remove it, right, then therefore the new center of gravity shifted over to this side. So the moments about the same rate pivot of the new cut out piece of the new cutted piece, which is 3/4 mg, right, would have balanced whatever that was missing from here. So it's kind of like it's a very stupid philosophical kind of question. There was another version. The one that actually came out was one of it's a circular disc, and there was a hole cut out in the middle. Right, it's sitting on the floor, right, like this. It's sitting on the floor, and the question was asking like kind of like, um, we had to apply a force to keep it in place. Right, we had to apply a force to keep it in place like this. We had to apply a force like here to keep it from rolling. Right, rolling to the side. Uh, Sorry, hang on. Just need to get rid of that damn thing. Yeah, something like that. And then the question was like, oh, what's the amount of force, right, that's required to keep it in place, right? So the thing is that like everyone started to try to find out where the new center of gravity is, but basically this is how it works. If your that missing piece was put back inside if the missing the hole, right, was filled up with that piece again, do you need to use a force to balance it? No need, right? No, the moments. Yeah, the moments of this F times D1 is basically the mg, the missing piece, times the pivot is here, so times this shorter distance here. Like I'm gonna call this D2. Yeah. So yeah, that was pretty much it. That's the way to solve it. There was no like, yeah, and it would have frustrated the heck out of everyone because like it's so like after you hear it you'll be like, shit, it's so simple. Why couldn't I have thought of it, right? Um, but it is not simple. I don't think anyone should think that it's that simple. It's, of course, like it's just like how Einstein came out E equals mc squared. It'd be like, wow, that's such an elegant equation. But you know how much mess and how much shit he had to go through just to reduce it down to E equals mc squared. It's the same thing here, right? So I think the idea here is um Occam's razor, whatever is the simplest method to explain it, that's the explanation, right? All right, so that's the one there, and we have a last one. Actually, we're at the last one already. Whoopee! Oh gosh, this sucks. Oh gosh, you huh? Huh? What? Oh, dude, damn it. That like there is ain't no way in hell is ever gonna be that. All right, let me just tell you that first. There ain't no way in hell is ever gonna be that. You have to write this down. Please write this down like 3 times now. Change in KE will always be half mv squared minus half mu squared. Never ever, never ever, never never ever. Yeah, no, final minus initial, initial minus final, it doesn't matter, right? Never ever 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 never ever. All right, write this down. Like this is completely wrong. I just did this with the class. No, yeah. So the thing is that you've got okay. So what happens is that you I get a sense that you have this kind of like this tendency to rely on old habits, right? So my advice to you is like uh be deliberate with your learning, right? I mean, you're still learning. No matter what, even in army, you'll still be also learning. You go to university, you'll still be learning as well. Be deliberate. Um, if let's say, for example, you're presented with uh, like like you did something, you thought that was right, and it turns out wrong, right? And then you figured out you sort of you if you couldn't figure out why, then my job is to tell you why. But you have to then really just tell yourself that from now on I really need to get rid of that because it's about efficiency pass. It's not about like I like uh how do I say it's not like you're not allowed to make mistakes ever again. It's not that at all, but it's about efficiency. the the lesser number of times you can repeat the same mistake over and over again, the more time you have to learn new things, right? So, for the sake of learning new things, you gotta tell yourself you gotta get it right this time. Maybe the second time is fine. Third time is a bit like, fourth time is like, what are you doing? Fifth time is like, what's going on, right? So, so try to be a little bit more deliberate with the with the process, okay? Don't just skim through it. Yeah. All right. Okay. Just be extra careful tomorrow. Tomorrow is just MCQ, right? How was the paper so far? The other papers? You cannot remember? Okay. All right. Okay. Okay. That's also okay. But it also means that you probably will have to be very deliberate with your corrections once you get it back. You have to go and spot things like repeated mistakes. Like, oh, you made it this time round, why are you doing it again? Number two, knowledge gaps. You got to look out for your knowledge gaps. Like to me, like today you told me, like, the way I look at it, geostationary is a knowledge gap, right? Uh, when you mention I don't know. So you know, you even if you ask me multiple times about geostationary, I probably did not sit down and explain the whole geostationary thing because that thing takes about half an hour, right? So far, all the lessons that we've had, right? I mean, you joined like you didn't join since last year, right? So the question is, did we actually have enough time to go through a lesson where I can spend half an hour doing geostationary satellites? And the answer is I even if there was, I wouldn't want to, right? Because it's already been done. So whatever questions you have asked me so far about geostationary, if it still didn't click, and I keep saying go back and watch the recording, right? It's because I refuse to go through half an hour of geostationary satellites, right? And the reason is because you have so many other things, right? And it's a factual thing that you can actually get very easily once you watch the recording, you know? So that's your time, right? So my time is to just cover the things that is seemingly impossible to cover, the really technical ones, like the stupid, like the presence in form of absence question, this one here, that sort of thing. Like, I mean, I would spend time going through this, right? So you have to make a mental note to yourself that like for all the knowledge gaps that you will uncover, right? Once you get back your prelims, there will be, right? So there will be. Well, let's not try to sugarcoat it, right? There will be knowledge gaps. Then like what are you gonna do about it, right? Are you gonna ask me? Because if you ask me, I'll just give you a very short, sweet version, right? And then I'll just tell you that, oh yeah, it's done this way, that sort of thing, you're missing this out. But you're not getting the full picture. So I need you to get the full picture. How do you get the full picture? You gotta watch the video. Okay? Full picture. Full picture. Always go with full pictures, right? So I don't know whether you heard me say it the other day or maybe I didn't, maybe I did. I hate stupid things like crash courses. Crash courses are the number one poison in the students like way of learning. Because a crash course is it's very enticing to do a crash course. Dude, if everyone can survive a crash course, then everyone will be getting rank point 70 using crash courses. That ain't gonna happen, alright? Crash courses are great marketing tools for tutors. You get what I'm saying? It's like if I sell you, if me, Samuel Leong, sells you a crash course, you know that I'm trying to con you into buying one of my crash courses. Yeah, correct. I mean, it's a thing. It's a great marketing tool, right? And students love it. Students love it. So some students will argue and say like, no, but the crash course has helped me, right? If it has helped you, great. That's because you probably have some basic knowledge, and the crash course touched on all the points that reminded you of it. But for someone who doesn't have the basic knowledge, dude, you better go get back to the, you know. So I would tell you that any okay, if I were to do a skim through, okay, literally it's a skimming through. You want the full picture, go watch the recording. If you got something wrong and you ask me why is it like that, and I tell you that's the reason why it's like that, okay, and then you realize that, oh shit, I know I really need to go and figure out this whole geostationary thing all over again, then yeah, please go ahead. Something like this here, this is a out of pocket question. You know what I mean? This is me explaining the underlying basis of this is moments. Don't tell me you don't understand moments. You understand moments. There's nothing in your notes, nothing in my notes, nothing in the textbook, if there was a textbook, that will explain to you why you're supposed to use you know, why you're supposed to find the center of gravity of the cut piece of metal from a cut out, from the weight of a cut out piece of metal. It's like, you know, there's nothing like this is an application, this is a philosophical question, you know. Like do what you can have control over. Knowledge gaps. So if you have a knowledge gap, go and run through that thing again, all right, from the start. Okay? All right. There is still time. There is still time. There is still time. But what I'm afraid of is have you uncovered all your gaps? That's the game every year with everyone, right? Have you fully gone through enough to uncover all your gaps? And when you try to patch your gaps, what's the most efficient way of patching gaps? Okay? Always remember whenever you're trying to let's say for I mean if you got like if you got like a wound or something like that, like there's something, like maybe a dog bit you, okay? Let's say a dog bit you, right? What do? The if you go to the hospital and you tell them that a dog bit you, do you know the amount of shit that you have to go through? They will have to wash the wound, they have to cut it open, they have to scrape out some of the flesh, they got to test it for rabies, they have to wash it many times over, then they sew you up. You know what I mean? They don't just, oh, here's a plaster, tap, all right, go home. Yeah, I mean, it's basically, yeah, but the thing is you're gonna, I mean, the whole idea is that, like, you make sure you go back to the basics and you cover that ground. Don't just, don't just like, oh, you mean this question is done this way? Okay lah, the next time the question comes out like that, I'll do it the same way lor. It's never gonna come out the same way, dude. Right? It's always gonna be some different form, right? And it's the underlying like concepts, okay, that you need to apply. Um, I don't want to make you worried the day before your exams, but I'm just saying that whatever it is after the exams, please think about how you want to manage the way you prepare for the final exam. Okay, right? Have a good think about it. I'm gonna take a break. I'm gonna get the JC2s to take a break next week and probably the week after as well. Maybe just a 1 or 2 week break. I don't know yet. I think maybe a 1 week break is in due because I'm so done with you guys for now. I know. I mean, you guys need to have a break. You cannot. Yeah, you gotta have to shut off completely for like 1 week at least. Maybe the week for the following week, maybe I'll restart on a Thursday, right? But that means kind of like so the next time I see you guys will probably be like 2nd of October. Yeah, yeah. I will still hold this Sunday's lesson, but I think by the time everyone else's prelims will be over, I'll still see them for their respective things. But I won't hold next Thursday, I won't hold next Sunday. So it's most likely the next time I see you guys will be like 2nd October. You should you have to like the last thing okay, the stupidest question ever is the question that was not asked because you were too afraid to ask. That's yeah, you know what I mean. Of course, think carefully first before you ask it, right? And then I mean, if you ask this question and then like 2 weeks later you ask me the same question again, I'm like, what the hell, dude? Right? You see, it's okay to forget how to do this and you want to ask again. With me, the idea here is if you forgot how to do this question, right? Ask for the recording. That's not a stupid question. You'll be like, hey Sam, I remember, like we did this question, but I really truly forgot how it was done. Can I have the recording of this again? Yeah, no problem. I mean, I have it. Yeah. That's why I emphasize so much on recording my videos. That's why you see me, I do this thing where I have a program where I cut myself out and put myself on the computer screen like this. Like I can literally see myself on my own screen. Like I know what I'm doing. Yeah. It's my own program, by the way. Yeah. This one here, this thing here, you see this one here? Yeah, this yeah. I mean, you see that label everywhere else, right? But they did this exactly my software. No, I don't. I just hired someone to do it. I knew the exact specs of it. Like I knew what I wanted. I even told the guy like which um table of functions to use, and I even provided. Huh? What? Everything. So yeah. So he coded for me and put it on GitHub. Of course, it's a private Git. And then I just created a exe on it. Yeah. If you have a Mac, it has a DMG as well. I just didn't put it on the App Store. Yeah. No, cause it's really useful. It's kind of like when I teach and I say like, okay, look at this. You know. Yeah. Yeah. You don't. No, but you know what's the funniest thing? I think the funniest thing is like a lot of people a lot of other tutors out there, like they approach me and they say like, hey, how do you do this, how do you do that, sort of thing, like how do you put yourself on this and how do you point to these things, like it's really useful. Th- yeah, and then they're like, oh wow, yeah, that's too much work for me. It's like I have to what, I have to install a program. Wow, that's really hard. And then they are the ones who can download TikTok really fast, right? And you can't install a program. Okay. What else, man? You jailbroke your phone, huh? Yeah. Oh, okay. Yeah. What do you want to do next time, though? Ever thought of computer engineering? Yeah. Yeah. I would say that like whatever it is, I think maybe it's a good idea to I don't know, right? So things might change in 10 years time and all. Of course, it's quite annoying. But I think there's one thing that won't really change, and basically that's like semiconductor engineering. Yeah, so if you go into computer engineering, try to find a way to specialize in semicon, all the chips and all the hardwares and all that. I think that market is still gonna be like 40, 50 years. I'm not talking about data, don't bother with data, don't bother with like coding and all that. That market is super saturated. We're talking about we're talking about like, like making chips and all that kind of thing because there's still a huge population of the world they don't have computers, and once their affluence goes up, they will have computers, and the world is changing their phones every other freaking year. So there was never be a like an end to it, right? Yeah. Yeah, I mean, yeah, sure, but that just means that there's a heckler of these like demand, right? Yeah, and you will always need yeah, that's one job that I don't think AI can take over, the the semicon yeah, making the thing that yeah. So I don't think so, man. I don't believe so. You need precision engineering. Micron. I know I'm. Do I know the family or they just acquaintance? They're acquaintance. Yeah. So. Yeah, it's crazy. Yeah. Okay. All right. All the best for tomorrow, and then take a break, and then get back to it again after that. I will assign a paper to do, and then when we come back, we'll just hit the ground running with the paper. Yeah. Bye bye. Good night.